using our little cards, we can verify the examples in Fulton's book without having to draw excessively many diagrams. So for example, if we go to the section on row insertion and look at the first example, then that's this tableau here, which clearly is a tableau because numbers are increasing in columns and they are non-decreasing in rows. And now we want to insert another box into this diagram according to this row bumping algorithm. Let's say if the new box has the number 8 written in it, then we start on the first row, compare it, and see that it's greater than all the numbers in the first row, so we just append it at the end. That happens for all boxes with numbers greater than 3. It also happens for the 3, so actually you only check whether it's at least as large as all the numbers in this row. Then you just put the new box here at the end of this row. Now, but if instead of a large number we want to insert a 2 into this diagram, then we cannot just put it here, because now the numbers in the first row wouldn't be non-decreasing any longer. So what we do is we look for the leftmost number that's strictly larger than the number we want to insert. That's the 3 here. And this box with the 3 gets bumped one row down. And the 2 gets here. So and now we do the same thing on the second row. So we cannot just put it here because it's less than 5. So we go to the left, to the left, to the left. As long as we're still, the new thing is still strictly smaller than the boxes here. So it's this 5 that gets bumped down. Now this 5 gets bumped to the third row. It bumps down the 6. And now the 6, it can just be appended to the fourth row. So we got this new tableau after inserting the 2, and we also got a new diagram. Recall that the diagram is the shape of the tableau. So the new box, maybe that's not dark enough. The new box is this one here, the box with the number 6. Before we had a diagram of this shape, and now the new diagram has one box more here in this position. Okay, this row insertion algorithm is invertible in the sense that if you know what the new box in the diagram, the new box in the shape was, then you can undo what we just did before. So we forget how we got this diagram. We're just told this is the result, this is the new box. So we start with this number 6 here, and we see that it's not on the first row, so obviously it got bumped down from the row above, from the third row. So which number bumped it down? It must have been the 5. Cannot have been the 4, because the 4 would have bumped down the 5. So the 5 bumped down the 6. Now the 5 got bumped down from row 2, and well, the 5 got bumped down by this 3. Cannot have been the 2, and we only go as far in from the right as we have to. So it must have been this 3 here that bumped down the 5. So what we do is we look for the rightmost number that's strictly less than the thing we're moving back upwards. So the 5 was bumped. The 5 was bumped down, and the 3 was bumped down from the first row. So this can only have happened with this 2 bumping down the 3.